Welcome back to Intel Edge Software Hub training. In the previous video, we saw how a cloud developer like Andrew could deploy their deep learning models and applications at the edge with a simple and extendable Intel pipeline. Today, we will see how we can customize parts of the whole cloud to edge journey. Hey, Andrew, welcome back. How do you feel about the cloud to edge journey now?
Much better. I usually spend too much time reconfiguring things. It's so nice to have a tool that can help speed the deploy time for my applications.
I'm glad that we could make your journey less stressful. Now, not only will you be able to go cloud to edge seamlessly, but Intel can even help you customize your applications and even find the right hardware.
All right, where do we start?
Well, OpenVINO's mantra is write once and use anywhere. So first, let's convert models to an IR format. IR stands for intermediate representation. Head over to your SageMaker and use the Jupyter notebook sample that we have provided, and you will be able to convert TensorFlow and Keras models to OpenVINO IR format using OpenVINO's Model Optimizer with just one line of code. For now, it is just converting models from TensorFlow Hub, but you can use this utility when you are done training your own models. Very soon in near future, we will show you how to do that. But for now, let's focus on pre-trained TF Hub models.
Tell me, why should I convert models to OpenVINO format?
I'm glad you asked that. There are many deep learning frameworks in the industry, such as Caffe, TensorFlow, MXNet, and new one every few months. And you would like to use all of them as your use case demands. On the other hand, Intel provides a lot of hardware to choose from. CPU, integrated GPU, well, that they exist with your CPU, a VPU, visual processing units, and representation of these deep learning models is different from one framework to another. On top of that, each of this hardware has different instruction sets and programming models. So rather than making you learn how to perform inference on these individual hardware, Intel has provided a common API called OpenVINO. That's what Model Optimizer precisely do. No matter how the model is represented by your deep learning framework, Model Optimizer will convert it to an intermediate representation. IR has two files, a bin file and an XML file. XML defines topology, the layers, the connectivity, and the parameters. Bin file defines that holds all the weights and biases.
Okay, so it's kind of like a mapping software.
I'm glad you mentioned that. Isn't it true that you can squeeze more out of your system or code with some optimizations, right? Well, that's exactly what Model Optimizer is doing, optimizing the models by using all kinds of technique like fusion of layers, batch normalizations, and more. These are hardware agnostic optimization, which can save you a lot of computation and memory. And that is not it. Last step is adjusting the weight format. Most of the weights are floating point 32 format, but devices like integrated GPU can run faster with floating point 16. So why not convert them?
That's great. So big question here. How does Intel go about enabling cloud developers like myself to use the OpenVINO Model Optimizer inside of something like AWS SageMaker?
Well, I would call it magic. Uh, we deployed OpenVINO Docker image inside your SageMaker instance, and the utility we have written interacts with the image or the deployed image as an inline function call.
So once I train and test my own models, can I convert them to OpenVINO IR using the Model Optimizer in AWS SageMaker?
Yes, as long as the model framework, topology, and layers and operations used in the models are supported by OpenVINO Model Optimizer, you can use your own models.
How long will the model optimization take after I run all the cells in the Jupyter notebook?
It totally depends on the instance size you choose and the size of the model.
So with Model Optimizer, I can choose any supported framework and then run it on any supported Intel hardware. That all that can be accomplished with a single line of code in SageMaker is super helpful. But what hardware should I choose?
That's exactly what we thought. Next, with a single click, you will be able to benchmark your newly converted OpenVINO IR model across multiple different Intel hardware within Intel DevCloud for the edge.
How does a sample benchmark Jupyter notebook work?
DevCloud for Edge is a cloud-based sandbox environment where we have made a lot of hardware available to you. Our sample application takes the model that you optimized in SageMaker and stored in S3 bucket, and then runs a benchmarking application provided by OpenVINO on it.
What can I expect after I run the benchmarking on my model?
You will be enlightened for sure about the performance you can expect on Intel hardware, and you can procure one accordingly based on your use case needs.
This is great. And I can see the performance of my model across all the hardware. So convenient. And I didn't even spend a single cent. So I'm starting to piece it all together. Now that I have my own model, I can start to customize the AWS Cloud-to-Edge pipeline, right?
Yes. And finally, using AWS Cloud-to-Edge pipeline use case from Intel Edge Software Hub, you will be able to deploy the new models at the edge.
Hey, wait, the use case came with sample video, but is it the only thing I can use?
Yeah, that would be very boring and limited, right? Taking data from your choice of input source is extremely easy and no code change required. Lambda inputs are controlled with environment variables as part of Greengrass deployment. One of them, input source, as the name suggests, change that to /dev/video0, basically whatever your USB camera is attached to, and you can use your USB camera. By the way, do not forget to plug in the USB camera before deploying the Lambda. I also tested it with RTMP feed from an action camera that I own and a drone also, and it worked like a charm.
How about changing inference hardware?
Ah, as simple as changing the input source. By default, it's set to CPU, as that's what we expect for people to start with. But as you get the accelerator, or you want to try out new things, you can change that parameter to GPU for integrated GPU or VPU if you have a Myriad X on hardware with you.
How about even changing the model?
It might sound like I'm repeating myself, but it is as simple as replacing your camera or the hardware. In this case, your model just put the model in a folder on the device and change the model path in one of the environment variables. In near future, we will be leveraging the AWS Greengrass machine learning resource to deploy your model seamlessly from cloud to edge. So stay tuned.
Wow, this is amazing. Intel's providing the tools to let cloud developers like me do so much more. When I'm developing, I like to go on a journey the way I want to. This sort of customization lets me do cloud to edge my way, powered by Intel.
Mhm. I'm glad, Andrew. What we build is going to help save you time. The question is, what with all this time and energy saved, what will you build next?
I have some ideas to make finding and sorting things around the house much easier. I always misplace things and I constantly run out of essential items and know that others have the same problem. I have a feeling that computer vision and Intel AI is going to help make my journey from idea to production much easier.
Well, we'll see you very soon with your use case. Thanks for joining us, Andrew.
Thank you.